Last video I showed you a couple tips and tricks about this program, and I just at the very end of it showed you how to delete a little bit of the DNA sequence. So we're going to just continue on with this process. So as I mentioned earlier on the first video about clipping the ends, it is very important, but at the same time the program isn't perfect and it does what it can. Some of these ends really still should be clipped. And I'll give you a prime example. This first sequence 004 H08. So even though we have this sample, and although it's been quote-unquote clipped, none of this is still very good sample. Some of it's okay, don't get me wrong, but you really want concrete sequences. And so none of this is super concrete, but starting right about here around bases 70 is about where it looks like it starts becoming fairly accurate. So again, we're just going to highlight that whole section, and notice how this is the first base pair in all of them. You look at this numbering right here, it says 1, so we can go 1 to 70 here. If you click here on this, in this little section, you'll see here that these ones do not match up. So that is a common misconception, that if you think, you come down here and you want to clip this next one and you say, oh, I want to go to 110 base pairs right here. That's where I think it starts getting good. You'll think 110, no, but in comparison to the very first one, you're at about 107. So it's just don't clip too many. Really make sure that your numbering is precise whenever you go to clip the ends yourself to make sure that you have the right thing. So as mentioned earlier, we're going to go about I believe base pair 70, which is fine. So you're just going to come here, highlight all the way up here to about 70, and then again, you're just going to come here to sample, delete, and you're going to fill from, I can't remember if it's the left or right, I believe from the left. So yeah, and so that's also really crucial which way you fill from, because if you fill from the right, then it adjusts all of the samples to fit in that little section. So usually if you do that, it'll throw all of the rest of the sequences off. So just kind of make note of that. So you just go through, that's the first step, is just going through and manually kind of clipping all the ends yourself to make sure you have good sequences. Then the next step is going through and finding a lot of your mistakes. Now this is probably the longest and most tedious part of all of them, but that's okay. It's just part of the game. It's something you have to learn how to do. So we'll go here to a random sequence error or a random sequence mutation that the system registered. And again, you can just come here, you see the red, just double click on the red in that section, and it's going to pull up the couple of different sequences that overlap within that region. So these are all the correct sequences in that region, and we don't care about those. Okay, so we want to come here, click on that mutation. Okay, so as we know, we're looking at this little section that all these sequences right here are correct, except for this one has a different one, has a T there, whenever all the rest of them have, it looks like G's in that area. So we're going to figure out why that is. So we're going to come here and upon comparison of these, it's pretty evident that these first two sequences, which match all these sequences right here, they all say the same thing, that there's a G there. This guy says there's a T, but if you look at his sequence, you can see why it's registering as the T there, because that's the wrong base. So the beautiful thing about this program is if it's wrong, it's wrong. You just come in here, click on that nucleotide, type in G, everything's right. It changes the nucleotide in there for you, and you're all set. So you come back here, bam, that error that was right there is now gone. Again, right here, this little region has a T where it looks like everything else is registering as something different. Well, and everything's registering different, but they're the same but different. So all of them are registering C's instead of the T, like this one has. So again, I like masking the matches so you can't see all those, but it's nice because you can see the errors. So we come here to this region, pull down. Okay, looks like DNA polymerase kind of went crazy here, or just something happened with the program that just went crazy, your sequence isn't right. Again, come in here, looks like it's probably supposed to be a C with all the rest of them. You're going to type a C in, it's corrected. Alright, that's part 3 of the video. We'll continue with part 4 in just a second.